Okay, so I started the recording. We will record this this workshop like all the others, and then have it online. So, hello everyone. I think we can, like, the nice thing of being a small group is that we can keep this quite interactive and informal. Now, I see that some don't actually have the mic, so we will use the chat. And otherwise speak and exchange. So my name is Francesco Gardumi. I'm a researcher at KTH Royal Institute of Technology in Sweden. And I'm on the team that works with the EU-funded Horizon 2020 EMBERS project. And I'll tell you a little bit what this is about. Project has several partners across research and industry, and is coordinated by INEGI in Portugal. And with me is a team of modelers and code developers that work in the project. So Shravan from the team at KTH, and then Jose, Bilal, and Sergio are here as well. Yeah, you'll get to know them. They will present as well. So this session is about showing you the EMBERS heat and cold matching platform. So it's a platform basically made for assessing options for matching excess heat and cold from industry with various sinks within industry or outside industry. And it's quite a unique tool in the sense that, well, apart from being completely open source and its code base being available on GitHub, you'll get the links through this presentation. But it's also a tool that combines quite different modeling methodologies in order to deliver a 360 degrees analysis and assessment of these options. And so it combines geospatial simulation, it combines economic optimization, you'll see, market analysis, and business models and business analysis. So the idea, I'll ask you, Shravan, to switch next slide. So the idea here is that, yeah, after this little presentation, the team will give you a bit of a technical presentation of the entire platform and its modules and the modeling methodologies behind it, and how these methodologies are linked to provide this comprehensive analysis. And then after that, you'll simply have time to play with the tool. Is quite a rich interface. So there's a lot that you can do in the tool. We have a case, a training case, a simple case that we prepared for you to play with and to follow step-by-step instructions while you do that. And you can explore the functionalities of it, the types of inputs that you put in, etc. Together with us and with the developers, and ask questions, curiosity, and give feedback. You'll also be able to run a simulation, perhaps. The time is quite tight. Let's see where we get. But if you follow all the instructions, you can run a whole simulation during this workshop, and then have a look at the results. The reports of the results are still work in progress, so they're workable and functional, but the user experience of those probably will be improved. But once again, we can have discussions and your feedback on that. And yeah, and then after having a little bit of this interaction, or during it, we can have some final discussion. Yeah, I will just ask Shravan in the meantime if he could put the link to the instructions, the instructions for the case that will be helpful for the hands-on experience, and also the link to the platform itself, so that who's here may go on and start creating a login and logging in, so that we're ready for that. Yeah, this being said, I will give word to Jose, who will start illustrating the platform and the case.
So, all right. Good morning, everyone. So thank you, Francesco, for the opportunity to present the platform. So Embers is a platform composed of four analysis modules and a main core functionalities, which receives the various inputs from the user, and the knowledge base, which should have some dynamic features. So the idea is that the knowledge base provides some default data for modules like equipment, technical parameters, default data sets, default data profiles. And then when the user goes into the platform, the core functionalities is the first layer of it. So if a user wants to add a sink or a source and to input all those details and check if the data inputs are consistent with the platform results. Then after the data being analyzed by the core functionalities comes into the simulation module. So you have the GIS, which finds district heating and cooling networks. So designs a map, calculates grid costs and the best links between sinks and sources for the chosen group. Then you have the techno-economic optimization, which identifies least cost technology combinations for utilization of excess heat in district heating networks mainly. Then the market module simulates different market mechanisms, mainly decentralized or peer-to-peer, or centralized, of course, for the district heating networks, also to assess different revenue scenarios. And then the business module finally presents the results to the user in an economic format. So what's the net present value of the solutions found? What's the return on investment? Based on the interest rates, either being business or social interest rates. So that's a general overview of the platform. Okay, Shravan, next slide. Thank you. So as I said I'll try to summarize. So it's a platform mainly to map heat and cold sources and sinks, to design automatic routing and pipelines to the groups selected to analyze, to calculate heat losses in the network based on distance, sources and sinks and their temperature, the costs of the installation and network construction, pumping costs and all of those sorts, the cost of integrating sub-excess heat into a district heating network, integrating excess heat on site, so internal heat recovery. We also analyze options such as organic Rankine cycle for some excess heat streams that you might have, or either some a simple pinch analysis to assess internal heat recovery options for industrial users, of course. And then savings in energy sources and associated expenses, calculating the economic impacts, so revenues and costs of the actors involved in the energy community, the CO2 reduction impact with this heat cold network that the platform suggests, and the cost of converting excess heat into the electricity, as I said, via an organic Rankine cycle. Yes, the source code of the platform and all the modules are available on GitHub, and you can find the links later in the presentation. Shravan, next slide, please. So I will just give a brief description of the core functionalities. So the purpose of this module is to act as the main input interface, as I said, for sinks and source data input. to convert sinks and sources to be compatible with DHN. So this basically means for sinks to install some heat exchanger or heat pumps, depending if they need a temperature boosting on the sink side. And to perform internal heat recovery assessment for sources, as I said, so via an organic ranking cycle or assessing internal heat exchanger networks by performing a pinch analysis. All right. Thank you, Shravan. Next slide, please.
Yeah, thanks, Jose. I'll take over here. So this is a brief description of the GIS module. So the GIS module, as the name suggests, is the spatial dimension of the Embers platform, bringing in the spatial dimension of the district heating network or the cooling network that needs to be analyzed. So the main functionality of this module is to compute and determine the least distance connection between the sources and sinks, thereby creating the district heating network between these sources and sinks. And apart from that, it also calculates the thermal losses in the network and the investment costs of the resulting network. So it is organized as two sort of sub-modules. One of the sub-modules to create the least cost network, and then the other sub-module which designs the capacity of the pipes in the network and optimizes the distance between these sources and sinks to create the least distance network. And then based on this optimal network, it calculates the investment cost of the district heating network that's created and the thermal losses. There are also other functionalities which will be released in subsequent versions of the modules where or the platform, where we'll have also a possibility to have an existing grid uploaded, so it can also analyze say an existing grid which is already there, and then the connections of these sources and sinks to an existing grid. So over to the next module in the simulation, which is the TEO, the techno-economic optimization. And here, as well as the name suggests, the main idea is to conduct a cost optimization of the technologies that are going to be used for the excess heat recovery, and then the optimal capacities of these technologies and the optimal operation of sources and sinks, such that there's an optimal matching between these sources and sinks that are present in the system. So here the main objective is to get the least cost mix of technologies at each source and each sink, and also technologies that are connected to the district heating network, which will act as a backup technologies in case the excess heat at the source is not enough to meet the sink demands. So that there are several constraints that one can execute in this model, such as regulation, the profiles of heat availability and profiles of heat demand, and also capacity constraints on the availability of excess heat and so on. So it also considers the main consideration is the techno-economic characteristics of the technologies, such as the capital, fixed and variable costs, and the efficiencies of the technologies. And like I said, the maximum capacities, and if there are any investment plans, that will be considered too. So the main parameters of the technologies that are analyzed by this module are openly available in a database. And in a platform release that's coming soon, there will also be a possibility to set capacity limits and heat generation limits on each one of these technologies, and also investment limits, such that if there is an investment plan for these technologies, that can also be considered. And yeah, the source code is available openly on GitHub, just like the other modules. And there's also an exclusive documentation available, which is linked, which is also found on the GitHub. So over to Sergio for the market module now.
Yeah, thank you. Regarding the market module, the main goal is to match supply and demand bids in heating and cooling systems. It models and implements the conventional pool, peer-to-peer, and community markets, which allows users to test and validate different market structures for selling and buying heat. In addition, the market module is divided in short and long term. The short term allows simulations up to 2 days with hourly resolution, and it intends to give an overview of individual agents' performance when subject to different market features. In this design, users are able to change some parameters and quickly check the effect of such changes on the market. In this way, the effect of different market settings can be studied in case studies with short time horizons. On the other hand, the long-term market analysis can be used to assess market outcomes for agents in wider time ranges, like months or years, and it can go up to 20 years. This is more suitable when users want to evaluate the profitability of potential investments. There are also several results and key performance indicators users can check in the market module, like the energy traded between the different agents, market clearing prices, operational costs, settlements, quality of experience, and so on. And that's it. The code is also available on GitHub through the link in the presentation. And I guess we can go to the business.
Yeah, thanks, Antonio. Over to Bilal now.
Yeah, but so for the business module, it's the idea is to take the input from the other modules and calculate the profitability, financial profitability of the project. And for that, we calculate different matrices, net present values, internal rate of return, payback period, and even levelized cost for heat. And we do all these calculations based on two different scenarios. One is the socioeconomic scenario in which we look at the project as a whole. But the second one is a private business scenario where we break down from the perspective of each individual actor involved. So if there is a typical iron or steel industry with excess heat supplying that excess heat to the district heating network, then the socioeconomic scenario would be looking at it as a whole, but the private business would be looking from the perspective of a district heating operator and that the industry was supplying excess heat and see how much they are investing and how much they're getting out. So we take in all the CAPEX that the techno-economic optimization module calculates, and then we also take in all the dispatch prices and revenues that the market modules calculate, and then we calculate these kind of metrics for the different scenarios. And a business model can take into account different ownership structure, which means all the different technologies that the TEO would decide to invest, who would own this technology, which source on sync would own that technology, and this is used as a proxy for different business models. And you can play around with the different ownership structure and then come up with a project that has a very good net present value for all the actors involved. So that's the idea behind it. Yeah, I think that's a business module part.
Thanks, Bilal. So now moving on to the practicalities of the GitHub and where we can find the repositories of the platform and the different modules. So we have the link for the GitHub in the presentation and also in the chat now. So this is the main GitHub page of the project, where we have several repositories containing module code of standalone and integrated versions, and also some code of the platform architecture. So in these repositories, you will find the prototype version or the standalone versions of each of these modules. So all of the 5 modules that we have listed here and described just now. So now if you just look at, for example, the repository of one of these modules, which is core functionalities, you will have several Python code files and also some test files and some test input data. So if you clone or download this GitHub repository, then you can use these test files and also establish your environment using the environment files in Conda environment or similar to set up the required packages for the Python codes and run the test yourself. And then you can also replace the default test input files with more complex cases input files and then run it. So this is one standalone version of the platform which you can of each of the modules which can be run on the computers if you want to. And of course, we will be demonstrating also how to run the integrated version of the platform. So over to Jose now for the case description of the workshop for today.
All right, so we want to show the platform. We have selected a zone in Greece, which is an industrial park called Volos Industrial Park, and there are several industries in this region with excess heat, and namely we have a steelwork company with temperatures around 900 degrees, and then some polymers company as well as a stone mill, and some bio industry. And also we want to, so the idea today is to test connecting some of these sources to nearby sinks, and the sinks that we can select from are, so we have industrial sinks that consume steam or make up water. And also we could test having a large office in the nearby area, so we can test adding a building and also a greenhouse. So these are two different sinks that are climate dependent, and it's a functionality of the platform. It will be good to test that. And also we have a town of Agios Georgios, which is roughly around 6 kilometers away from the park itself. That could be an interesting consumer of heat for some of you who wishes to extend the grid to that point. Next slide, Shravan, please. All right, so back to you.
Yeah, thanks, Jose. So the next part shows you the implementation on the platform itself. So once you have logged in to the platform, the first step is to create the sources and sinks that we just discussed in the last slide. So you will be creating each one of them using the objects button on the dashboard, and then selecting the type of object you want to create, which is a source or a sink. So we have here, for example, the creation of a source. So once you click on the source, you will see a window, something similar to this, where you will enter all the values that have been that are presented in the tables in the instructions document that's on the sessions webpage. So the first part of the workshop will be to create the sources and then the sinks, which are again going to be pretty similar. So objects, and then on the drop down that we saw in the previous slide, you will sink instead of source, and then there'll be a form asking for a set of inputs, which you find in the tables again in the instructions, which you'll have to enter here. So like we said, we're going to have 3 different kind of sinks here. So this one is for an industrial sink, where we'll have a specific set of properties for the industrial sink, and then we also have 2 other sinks, which are the office building, which will have different types of properties, such as building orientation and set temperature within the building and so on, to calculate the space heating requirements. And then the last one would be a greenhouse, which again would have specific parameters for the greenhouse to calculate the heating requirements for a greenhouse. So these are the different types of things that the platform can host, and we'll have all of these in the workshop for you to try out and create. And once the sources and things are created, run the simulation, we will first need to create a project using this button on the platform, and we will create a new project and give it a name as the workshop or whatever name you want to give. And once we before we save this, we'll also have to select the area. So once you have added all the sources and the sinks onto the platform, you will see something like this with all your sources and sinks shown on the map. So you can zoom out and zoom in in this map to make sure that all the sources and the sinks that you've selected are shown here. And then we can, using the button to select an area, we can select an area like this as a triangle or a square to fit in all the sources and the sinks, and we'll make sure that we select it only as big as possible to have the sources and sinks and not bigger, which would then lead to some long simulation times if we have a very big area selected here. And then once we have created the project, we need to create a simulation within the project. So you can have multiple simulations within the project where you can have different sources and sinks or different types of inputs to each of these simulations. So then we will start with a simulation where you can also give a name to the simulation, and it will always be a full simulation, which is what we're going to run for this workshop, which will be a simulation of all the modules that we just showed. There are also other types of simulations that are can be conducted on the platform, but today's focus is only on the full simulation. You can then proceed to choosing the sinks and the sources that we just created in the platform, and also select the region and so on, and then click on next, which will take you to the next step of the inputs. So the first step we will discuss with the core functionalities module. This module will already be getting its inputs from the sources and sinks that you just created on the platform. So basically just choosing the sources and sinks is enough to give the inputs for this module, because all of this in this table we will already be entering when you create the sources and the sinks. And the next step is the GIS module, which also has a set of several inputs, such as what type of resolution for the network we need. So the high resolution chooses all possible links. The low resolution looks only at highways. So there are several kind of functionalities of each of these modules, which are depending on these inputs, and all of these inputs are also found in the instructions document. So you look at, for example, the supply and return temperatures in the grid, the average ambient temperature of the region, the average ground temperature of the region, and so on. So these are going to be used for different functionalities within the GIS modules, such as calculating the pipe capacities or calculating the losses from these pipes and so on. So there are several lists. There's a form that you have to scroll down with several requirements of inputs to the GIS module. So this one is for costs of the network. So all these inputs will be used to calculate the investment cost for the network. And then the last inputs, again, consisting of the investment cost and some capacities and the specification of the terrain and so on. So which is all of these will be used again to calculate the losses and the costs of the network from the GIS module. Over to the TEO module now. So you will have 5 major inputs in the TEO module, which are going to be the sets or the structure of the model inside the TEO module. You will first select the region. We'll also be analyzing emissions in the TEO module. So you'll be analyzing everything as CO2 equivalent for this workshop. And then we'll have a weekly time resolution, which means we will have about 48 intra-annual time slices, and we'll keep the resolution slightly low for the workshop so that the case can run quickly, but then the TEO module can analyze up to hourly resolution. And we will select a time period of 1 year for this case. So we'll be analyzing investments until the year 2023 or just for the year 2023. We'll only use one mode of operation for this case. Mode of operation basically determines how many types of fuels that the technology can generate. So for example, for a CHP, it could be heat and electricity in 2 different modes of operation. So heat in one and electricity in another, but we'll only stick to one mode of operation. So in this way, it is defined that the CHP produces both of these in one mode of operation. But the other main reason to just have one mode of operation is that for the purpose of this workshop, we will not be using any storages to be analyzed with the TEO module. So we will delete by default, there are some existing storages in the platform input. So we will just delete those and move on without storages. And then lastly, we have some constraints that we can already set in the TEO module, such as the emission limit for the case, and also a maximum budget limit. So these will also be input according to what we have in the instructions document. Over to Sergio now for the market inputs.
So these are only for the long term. So the user should select the market design he wants to simulate. So it should be centralized or decentralized. Then the next three inputs are related to time horizon. So the user should select years, months, or weeks for their simulation. Then the recurrence will define how many of the time horizons will be simulated. So if you want 1 year, you'll just select one in the recurrence. Then the data profile, which can be hourly or daily, basically means for the simulation if it will run on hourly basis or daily basis. The yearly demand rate is only if the user intends to simulate more than 1 year. So for this case, it is not required, but if the user do not provide the demand for more than 1 year, must introduce a value here. Then we have the date in which the simulation is starting. Then the product differentiation, which is a feature to directly impact on the bilateral trades between the agents. Here the agents can select the CO2 emissions or the distance. And finally, we have the maximum willingness to pay, which is the utility. The sinks are able to pay in the market. Here we can use a constant value, or users can also uncheck this box, and then they can define one value for each sink. And that's it for the market.
Thanks, Sergio. Now over to Bilal for the business input.
Yes, I think the business input are relatively simple. The first one is the discount rate, where you're supposed to input two values, one for the socioeconomic discount rate and the other for the private business. And if you don't know the private business one, you can put it as same as the socioeconomic one. Then we have the lifetime of the project, which is in years. And then we have an optional variable, which we haven't implemented yet, but it's a CO2 intensity of the existing supply. But I think this is something that the core functionality also have. So in the future, we will remove this input. Next slide, please. Yeah, and then the grid ownership structure, it's basically the division of the grid cost among the sources and sinks that are involved. And it should be equal to 1. All of the sum of all the inputs should be equal to 1. So in the example that is shown in the snapshot, you can see that there are 2 actors who are owning 50% of the grid. And then similarly, we have the technology ownership structure, which basically decide that the different technologies that are installed at each source and sink, who would own those technologies. And the TEO decide which exactly those technology will be, but we don't go deeper into this technology. We just group all the technologies that are installed at a particular source or sink together, and then we see who would own this technology. So in this example, it's very simple that the source 1 is owning all the technologies that are installed at source 1, and similarly the source 2 is owning all the technologies that are installed at source 2, and similarly. It could be a case where a source 1 is owning all the technologies that are installed at source 1, source 2, source 3, and so forth. So you can play around with the different ownership structure. And in the beginning, there is also a default input with the simple correspondence, meaning that each source and sink would own the technologies that are installed at their premises. And then later you can change them as well. Yep, I think this is the last slide for the business module, Sharon.
Yeah. Thanks, Bilal. So after we've input all the inputs according to the instructions into the platform for each of these modules, we can create and run the simulation. And once the simulations are run, we will have the reports, and as we mentioned earlier, these reports or results are still work in progress. All of these results have been validated, and the numerical results are correct. However, the user experience of these reports are still being worked on, and we're trying to add more features so that these reports can be more informative to the users. We'll have reports from 4 out of these 5 modules, starting with the GIS module, which will show the installed capacity of the network and what the losses and the costs are from this network. And then we will proceed to the TEO module, which will show the installed capacities for the technologies at the source and the sink, and the and several other results such as the heat generation and so on. And then we'll have the market module, which will show the generations and the load and the bids for each of the agents in the market from the optimized solution. And finally we'll have the business module, which will look at the levelized costs and the net present value and the payback period for each of the sources and the sinks. Yeah, so now it is time to, or Francesco, do you want to take over and present this?
Yeah, so now it's actually time to just give it a try and experiment with the platform. I have posted again the link to the platform itself, where you have to create a login and then start working with it. Well, I posted again also the link to the instructions for a base simple case with step-by-step instructions that you might follow to create a case. I do notice that actually we have a bit of turnover here in the participants, and somebody just newly joined. Thank you for your interest. So I was actually thinking of maybe switching this around a little bit, and maybe we could use the last 45 minutes to instead show how we create a case on the platform, Shravan. That's kind of my idea. What do you think? So yeah. Doing it live, recording it also for those who were not able to join the session but had registered. And then, for instance, yeah, the participants here can follow along and do the exercise while we do it, and see how things are done. I'm also considering that some actually are not able to use the mic, so maybe it's a bit more difficult for them to interact. Do you think so? You feel fine with showing the screen and creating?
Yeah, sure, that can be done, no problems.
Okay, and I'll leave it to you, and yeah, we'll use this last time for this. But in the meantime, if there are any questions, please do write on the chat or speak up, because it's few of us and we can just speak.
Yep, I'll just open up the platform and start sharing my screen.
I imagine you might also have to delete the links and the sinks and sources you already have.
Yeah, but I think I'll start from another institution, so I don't think I have them there. So I think it should still be fine. I'll just open up the instructions as well.
Nice screen.
Go. We have that, and then the instruction. Okay, so we'll start from the beginning with logging into the platform. I hope you guys have some already created a login, or you can do that with this button, creating a login with your email ID and your password, and then you will get a verification into your email for your login. We can then start with the first steps as in the in the instructions document as well. So the first steps is of course step 0, which is to create the account and so on, and then log into the platform. And then the first steps would be to go to the dashboard and start creating these sources and sinks based on the inputs that we have in this instructions document. So I'll first start with that. So we will start with the objects and then creating going to the objects icon here, and then I have a few sources and things already. Or no, I have the wrong institution. So I just go into this and objects and start create. I'll probably delete whatever is there just to make sure that we don't have any overlap from before. So I'll start creating sources, clicking on create new source. The first source we'll be looking at is a simple source, and then the name is polymer. The fluid we have here is water, and we need to enter the latitude and longitude based on what we have in the table. So we will use custom marker for that, and then I'll just copy in what we have in the table in the instructions document. So we have the latitude and the longitude. Then we can just check just in case we have everything right. So it's, yeah, now it seems to be fine. It is in Greece, close to Agios Georgios in the Olos Industrial Park. So this seems to be fine. We can move on then to the supply temperature, which is 80 for this case, the target temperature of 60. We have the fluid CP here, so we do not have any capacity for it. So in this case, the platform will be using the fluid CP and the mass flow rate to calculate the capacity of the sink. And then we have the daily periods, which is basically for how long the source or sink operates in the day. And we need to know if it's working throughout the weekend. So we have an option for that as well. And then we have the shutdown period, which is basically the days in the year when the sink is or the source is shut down, and this source operates throughout the year. So this is basically empty. And the rest of this can be left empty because all of them are defaults, which we won't be using for the simple case. We then proceed to click on next until we have the save button. All of these equipment process and additional changes or more advanced functionalities, which will is not out of scope for this simple case. So we just leave them empty and then click on save, and we will have the source here, and we can also see it here on the map. So we can proceed now to create the other sources. So then again, proceeding with the same procedure as before, using the custom marker to enter the latitude and longitude and entering all the other inputs just like we did for the previous sink. And for this sink, we directly have the capacity instead of the fluid CP and the mass flow rate. So those are two different options which we can use to identify what the capacity of the source and sink are. And we also see that we have a shutdown period of about 58 days for this sink. So it's unavailable between days 182 and day 240 in the whole year. So yeah, these are certain practical conditions that are constraints that you can impose on the on the availability of heat from these sources of things in the platform, which will then be used to create the hourly profile of heat availability from the sources. And we can proceed to save the source and then create the next one. So in this case, we now see that the sink is the source is available intermittently. So we have an availability between 0 and 6 and between 22 and 24. So we need to introduce, when we have intermittency, we need to introduce the array like this, so that the platform knows when exactly the source and sink source is available for reproduction. And once again, this source is available throughout the year, so there's no shutdown. Now we have 3 of the 4 sources, so we can proceed to add the last source, which is the stone mill. And here again, we have the capacity directly, so we do not need to enter fluid CP and mass flow rate. And here we have an intermittent shutdown period. So similar to what we saw before with the intermittent daily periods, the input needs to follow a similar structure so that the platform knows when exactly the source is shut down during the year. We can proceed to save the last source. We've created one part of the first part of step 1, which is to add the sources. So just to point out that any values that are in these forms, which is not listed in the tables, those can be left empty for the purpose of this small demonstration case. When we have the more complex case, we will look at these functionalities later. So once we have all the sources, then we have the next step, which is to create the sinks. We'll go to the sinks and click on create new sink, which will be similar to how we created the source. So we'll first create the simple sink, of which we have 7. So we'll start with the first sink, which is called the beverage factory. And we'll proceed to have inputs, some of them which are similar to the source details, some of them are slightly different. I'll point out them as they come. So these all are the fluid and supply and return target temperatures are similar to how we have it for the sources. And similarly, we also have capacity, fluid CP, and mass flow rate like we did for the sources. And this sink will use the mass flow rate and the CP to determine the capacity. And we'll also have daily periods and functioning during the weekends and shutdown periods similar to the source. Additionally, we also have a reference system, which is basically looking at what is the current system that is being used for heat supply or cold supply in these sinks. So in this sink, we have a biomass-based heating system. So it might be a biomass boiler, and then we have an equipment efficiency of 0.9. So these are all the inputs for the simple sink for beverage. So it's quite similar to how we have it for the sources, with a couple of additions at the end with the reference system. and the rest of them which are not in the table can again be left empty. So we can proceed to save this sink and then proceed to add the other 6 simple things following exactly the same procedure. So I'll go step by step to add them as well.
There is a question from John. Thanks for the question. So he was wondering whether there are any graphs available to consult when added heat sources which show the change in CP with temperature of flue gases.
Not really, not in this version of the platform. So we are only taking a single input for the CP, irrespective. So we're just taking an averaged out input of the CP for the based on what temperature is available. So we can't really change the source temperature and the CP are pretty much constant values here. So we do not account for the variation of CP with the temperature. So yeah, but that is something we could probably add in later versions of the platform. Thanks so much.
I would imagine that being possible in the sense that all of these are inputs that come from in principle from a database that we call Ember's knowledge base. And then they are kind of re-elaborated by the first module of the platform that re-elaborates quite some of the data used by the other functionalities, by the other modules. And so in that case, one could insert a varying CP as an input without risk, like curves of it, without risks of non-linearity, I would say.
Yeah.
Am I wrong?
Yeah, so we could add a linear variation to the, yeah, like Francesco said, more of a linear variation graph to the CP as well.
Thank you for the feedback.
Thank you. I'll just proceed now. This is exactly the same set of inputs as the previous thing. So we can save this one as well and proceed to the next. So this sink doesn't really have any shutdown periods, and it uses natural gas-based boilers for the current preference heating system. Those are the only changes from the previous one. So proceed, save this. So we have the 3 of the 7 simple sinks now. So we'll create the next one. So this is a sink with 2 streams. Basically, it has 2 different process heat requirements, one as water and one as steam. In the current version of the platform, we will add it as 2 different sinks. So we're looking at fisheye now, which has water and steam. So we'll have fisheye 1 and fisheye 2, so 1 for water and 2 for steam. But then in later releases of the platform, we'll be able to add 2 different streams within the same sink. So it can, to make it more user friendly, so that we don't have to add another sink. It can just be the same sink. And in this case, we directly have the capacity calculated. So we're not going to use the fluid CP and the mass flow rate. And the other inputs are going to follow the same structure as before. So we'll have fish eyes 2, which needs steam and not water. This, as we see, it's a cooling demand. So we have a supply of 15 and target of 8. So this is a sink which has a cooling demand. And in such cases, we will be using absorption chillers to make use of the excess heat and convert it into the required cooling energy. So in this case, we have no shutdown periods, and we'll have an electricity based chiller, which we'll use as a reference system for the cooling demand. And then we have the last sink, which is the district heating network in the town. So we'll have a connection point for the district heating network. So this is not an existing district heating network, but it is something that we're trying to analyze based on the case here. So we just have a connection point for the central town. So we're just looking at the cost of connecting these to the central point of the town right now. And then based on these analysis, it can be further addressed if it's feasible to have a more complicated district heating network within the town as well. And here again, we're considering natural gas-based boilers to supply the current heating demand. So now we've created all the same things. So we'll move on to the more specific sinks, which are the office building and the greenhouse. These are different templates, not simple sink, as we'll see now on the platform. And these are, yeah, the inputs are more specific to the requirements of these things. So we'll create a new sink as we've been doing before. But then the template this time will be building instead of a simple sink. The inputs for the latitude and the longitude are still similar. And then we have a building type option here. So it can be either office, hotel, or residential. Now this is an office building. We have the building orientation, which is south in this case. The number of floors is 2. The width to the floor is 100 meters. The length is 50 meters. 5 to 3 meters. So these are all very, very building specific parameters that then the platform uses calculate the profile and the cooling or the heating demand for these buildings based on these inputs. And we have some inputs like before, so we have an intermittent daily period here as well, and then the Saturday and the Sunday on functions as before, and the shutdown period as well. So we are looking at a conventional heating and not a low temperature heating for this case. These are not really, these input can be left as they are, so those are the default inputs. And then we finally have the heating reference system, which in the case of the building is a electricity based boiler. And then for now, we're not analyzing the cooling, so we can leave the cooling reference system empty. Oh no, sorry, has to be electricity here as well. So that's a typical example of how the platform looks at any errors in your input. So you're already notified here if there are any missing inputs. Not sure if that was saved. Okay, it was. Let's look at it to make sure everything is fine. So you can use the I symbol next to the sink names just to make sure that everything is fine, just in case you're not sure if it was saved all right. So we have 8 out of the 9 sinks now. Let's proceed to add the last one, which is the greenhouse. So in this template, we'll now have the greenhouse through the simple sink, and proceed to add the latitude and the longitude as before. I think that was not what we were expecting. Yeah, now it's much better. Again, we'll have greenhouse specific input in these forms. Yeah, so now we've saved the greenhouse, hopefully, and we have all the sources and sinks for our case. Yeah, sink has been created successfully. So we have all the 9 sinks, and then we can just go back and see if we have all the 4 sources. Yes. So now we have added all the sources in the sink. We can proceed now to create the the project, which is the next step in the, so now we are done with step 3 or step 2. So now we have to create the project and then the simulation. So we'll proceed to the creating the project first. So let's create a project here. And then we just need to go back to first see all the sources of the thing. Cancel this, go back to the dashboard. So here we see all the sources and the things to make sure that they're on the dashboard as well. So it's easy for us to choose the project area. Okay, I'll see them here. So yeah, now we have them. So we just need to click on these to make sure that we see them. So now we can see the sources and then the things as well. So we can go now to projects again and create the project. So now we see them here. And then as we demonstrated in the presentation, we can then select the project area. We need to select it again. Sorry, we need to cancel this and create again. So we can only select it once and we need to make sure that it is right. So we can just zoom out or zoom in enough to have all the sources and the things, and we just create a project area for that. We just managed to cover all sources and things and not make it too big. So we save this and then we now have created the project inside which we need to create a simulation now. We will go for a full simulation of all the modules. So we can add one by one each of these things that we just added, or you can just click on select all if you just want to select all the things. In this case, we have only added the things for this particular workshop demonstration. So we can just click on select all, and similarly for the sources as well. Or if you, so in case if you have more than the number of sources of things you need, you will need to pick them by hand and select it. So we now have selected all the sources of things we need. So then the platform knows which one to analyze. And then we can proceed the inputs of each of the modules. We're now on step 5. So we did step 3, which was to create the project and the simulation and choose the source and the sinks. So now we are in step 5, which is the input for the GIS. So we'll follow the table and the images here to proceed to make the inputs. So inputs in this case are going to be left default for all of these. So we have filled in these default values into the platform to make the user experience a bit better. So if in case you're using these default values, or if you do not have specified values for these, like in this case, we can just leave the default value. And these default values are more or less applicable in generic cases. So that's why we have them here. And you can, yeah, unless you want to, you have more specific values for your case, you can just let them, and those are like global default values that we have used. So we let them be now, since all of these default values are what we need for this particular case. The next step is the TEO. So here we'll have to enter the region, which is already Greece, what we needed. We have the CO2 as the emissions that we need to analyze. In this case, we have weekly as the time resolution instead of monthly, so we need to make that change. 2023 is the year we're trying to analyze. Like I demonstrated earlier, we only need one mode of operation. So just use the S here to get rid of 2. And we will not be analyzing any storages. So we can click on these buttons to delete these storages. And then we have the emission limit and the budget limit that we need to enter according to these values on the instructions. So these are high enough values to ensure that the case runs without any infeasibility for this case. But in they can also be introduced values that are used to make sure that the emission doesn't go beyond a certain limit as well. Next, we proceed to the market inputs, which is step 7. So we are very close to finishing the inputs for this case. And we see again here that the inputs are, we're trying to use inputs quite similar to the defaults. So the yearly demand rate is going to be 0. And the start date, of course, since we're analyzing 2023, will be the 1st of January in 2023. And the maximum willingness to pay will be 0.7, and we will just use a constant value for this case. And finally, we have the business module. So we'll have a discount rate of 4 and 4 for both socioeconomic and private economic scenarios. The lifetime of the project is 10 years. The CO2 intensity in this case is 5. And then the grid ownership share, this should include all of the actors. So each source and sink is an actor who owns the grid. And also there's in this case, we have also considered, or this version of the platform, we considered a municipality or a district heating company that also owns the grid to an extent. So we'll be looking at 14 actors in total. So this array should have 14 elements in them. So we say that one of these actors owns the network completely and the others do not have any share in the grid ownership. So this is a default setting that we have used, but in other cases you can divide this between the actors, or some of the actors could own it and not own it as well. So in the end, it should add up to 1 is the sort of idea of this actor share. So this basically specifies how much of the grid each actor owns. So it's one of the major inputs of the business model. So now we're done with all the inputs, or no, we still have the advanced properties was already filled in for us. So this again is based on the default inputs, and we're going to use that. As it is, this shows the owner of each technology. So so this is quite basic. So the platform already fills it for you. So it's basically telling that any technology at source 1 is owned by source 1 and so on. So unless there's a big change, so for example, if one of the industrial sources is investing in all of the industries, or if there's a combined investment, also we need to look at changing this. But for this case, we're not going to change this, and we're going to let it be as it is. Then we can proceed to create the simulation. And using this button, we can just start running the simulation. So there are 2 ways of monitoring the simulation. So we can just monitor it in the window here, or if we click on the eye symbol, which just opened up this, we see that the simulation has started running. Just need to refresh this to make sure that, yeah. Then we have a bar here which shows the status of the simulation. indicating how far the simulation has progressed, or we can go here into the using the I symbol and then the clicking on the simulation and then looking at what module is running. So we now know that the CF module is running the two functions. And if you are on this particular window, we just need to keep refreshing to make sure that we have the latest here. But here you will see the progress on the bar automatically. So we just wait now for the simulation to run. Takes about 5 to 10 minutes to run the simulation, and then we can have a look at the results.
Yeah, we're actually coming to the end of our session, because now the plenary will start in 5 minutes. So it will be just in time to see it complete, probably. But I would say if anybody wants to stay a few minutes longer, maybe we'll go on recording also how the results look like. But otherwise, of course, feel free to leave when you have to. And yeah, just to add from my side that of course, with a short amount of time, there's a lot that we don't manage to cover and to show you. But in the instructions that we shared, and that are also on the link of this session, there's much more detail, and in the documentation that we put the links of as well, there's even more details. So all the technical details of all these methodologies and the links between them. And then here in this page in particular, the one that Shravan was showing a second ago, with there's all the here exactly, there's all the detailed information on what is given as input and comes as output of each of the calculation modules that are linked, and the final reports on them. And when there is an error, you'll get one of these boxes, but it will be red, and you will get the error report as well. So then the more one goes in detail, of course, the more are the possibilities. And the good bit of it is that all of this is open source and can be looked into. Yeah, just adding that to cover the gap of the simulation time, and then we'll give it back to Shravan.
Yeah, thanks, Francesco. So the good part is while the simulation is running and as the modules go on, we can already see the reports of some of the modules, so we don't have to wait too long. So we now already have the report of the GIS module. Here we see that we see the installed capacity between of the network is 3 megawatts, and we know the loss of the network, and then it cost about 14 million to invest in this network. So we have a detailed solution. So we're still adding to this report, and in the subsequent versions of this report, you will be able to see a map of the sources and the sinks on this report, and you'll be able to visualize more clearly where these sources of the sinks are located, and what is the exact network that we have in this map. So it will look something like this. So this is an example of the map that we have obtained from a standalone version of these rounds. So we have all of these sources and the sinks, and then we have the path, and then the path will be in blue, and then we have the solution or the network itself that is established between these sources and sinks in green. So you can see exactly where this network is and how it is located and how these sources and sinks are created. So this will be added to the report here in a more detailed fashion than this. So you'll be able to select and see what each source and sink is and so on. So that is about the GIS report. Now we have the TEO module, which also produced the report. So this report will contain the capacity, the heat generation, the share of the sources and sinks, if there is any storage, the capacity of the storage and the operation of the storage and so on. So we'll first start with the installed capacities of each technology at sink and source. So we have the large table on the graph, which visualizes for all sinks and all sources. And then we also have the button to look at it for each source, what the investment is. So here, for example, one thing that we're working on now is to make this more user-friendly and replace these source IDs with the source names. So in the future, you will say, for example, have the accumulated new capacity for, say, the source iron and steel, or the source beverage, and so on. So yeah, that is something we're working on. So we can look at the capacities for each source and each sink. And then we have the grid specific, which is basically the backup technologies. So in this case, we know then that the sink demand, or the source sink demand, is higher than the source capacity. So we need some kind of backup technologies. So we use a natural gas boiler here. And if we impose more emission limits, we will probably use a biomass boiler in this case to supply the heat. We don't have any storages in this case, since we do not select any. And then we see the annual heat generation in kilowatt hours from each of these technologies, from the sources and the sinks. So we have the sources first. We see what heat is generated from each source and from what technology within the source. And of course, we have the same with the graphs for each source to look at it in more detail. And then we have the heat and cold consumption for the sink. So we know again, we see again what the heat and cold consumption is for each of these things. So we look at, for example, the again in detail for each sink, what is the heat consumption or the cold consumption. And yeah, like I said, we're working on replacing these IDs with the names. And then we have the profiles of the heat generation from each source and each sink, and we can look at more detail. So in this case, we selected 48 time slices, so we know the exact heat generation from each of these sources in the 48 time slices, and then we can look at it for each source just to understand what the profile of this source is, how these sources generate heat, and to what extent the capacity of these sources is used. And then, of course, we can look at the sinks consumption. This will be basically the same thing as the demand profile in this case, since we do not have any storage. But when we add storage, it'll be interesting to look at how storage sort of flattens the peak in these cases. So that is one more functionality that we can add to the case, and then look at how these the consumption profile changes. Yeah, and then lastly, we have the overall heat and cold generation and consumption. In this case, it was only 1 year, so the annual and the overall is pretty much the same. But if you have more than 1 year, the annual and the overall is different. And then we can look at in the final optimal scenario, what source is being used, how much, and then we can sort of look at this to the investments and the cost to figure out why the GEO module proposes a certain solution. Must be because, so if it uses only 1.74 of 866, that it's either because the capacity is too low or it's because it's too high. And then we, of course, have the emissions and the cost for each of the sources and sinks.
Thanks, Shravan. I think we may have to stop here. I wanted to give just to say one more thing. Bear in mind that the graphs here are looking very simple now, because this is a simple case, but simulations can be run for several years and with a resolution up to hourly. So then the insights become much more granular. But now a question from John. Would you like to speak up, John, please?
Yep, no problem. Yeah, sorry, apologies if I might have missed it during the presentation, but I know you're inputting individual heat sources at one point, and I was just wondering, is it possible to input, multiple heat sources in one go? So like a batch of heat sources, if you already have calculated the megawatts and the temperatures and their locations.
Yeah.
Okay.
Yeah, it is possible already in this version of the platform. So if you click on projects here, before you create a project, you have an option to import sources and sync. And there is a template Excel or CSV file that we use for this, and then you can download, and then yeah, it'll have all the inputs that is needed, and then you can input that and then just upload the file.
Okay, perfect. Thanks very much.
No problem. So we now saw also in this case that there was an error in one of the modules, and then we also know how the error looks right now. So a bit slow, but yeah, but it's just a red box like this which says you which tells what the problem is, and it's something with the inputs, and you can go back and change the inputs and run it again. So yeah, that is one of the functionalities as well.
Thank you very much. Then we'll leave it at this, and we'll join the the plenary. Thanks a lot for joining in here, for listening in, and please let us know if you have further questions at any point. Be in contact. We will share the presentation and the recording. And maybe also some more, you'll find all the relevant links on the presentation and also our contacts. Thank you all.
Thank you.